Welcome, my dear followers and students. This is part 2 of the lecture series on estimation and interpretation of the ARCH family models, which include ARCH, GARCH, TARCH, EGARCH, PARCH, FIGARCH, and FIEGARCH models. In this part 2 of the videos, I'll discuss how to estimate these models in EViews. So, I'm using this data, that is the stock price of Pakistan Petroleum Limited, that is a series, time series, and the name of this series is open, that is the open price of this series. Before I present this video, let me dedicate this video to my PhD students, Miss Shandana Said, who has produced and developed this presentation and the data. So this is basically her work, and she has submitted this work as a homework or as an assignment. So I dedicate this video to her. Again, this is the plot of the daily stock price of Pakistan Petroleum from 2012 to 2020, and it shows that there are certain periods in which there is a high volatility, which are riskier than the other time periods. So let me go to my data. Here is the actual data file. Let me show this to you. I'm interested in this series. Let me open this series. First of all, I would like to open this series as a spreadsheet. Now this data is from 2nd January 2012 up to 21st of August 2020, and these are the various values. Now let me show the graph of this series, and this is the graph of this series that I just showed in my slide. So since this is time series, so the first step is that I would like to check stationarity of the data at level. So I click this level and this intercept, and if I click this, the p-value is more than 0.05. So we fail to reject the null hypothesis, and we conclude that the series open has a unit root test at level. So since this series is non-stationary at level, so I would like to test its stationarity at the first difference. So I'll click first difference, and then after clicking OK, the p-value is less than 0.05. So this time I will strongly reject this null hypothesis that the series of the open in its first difference doesn't have the unit root, so now it is non-stationary. And after this, I will estimate the AR1, that is autoregressive of order first. So I will go to quick and then equation, and here I will write this equation, and so if I click this, here is my estimated model that I estimated with the least square. Now this data is not meaningful in its way, so I will check its ARCH test. Total number of observations for this is 2166, but included observations are 2164 after adjustments. This is the coefficient of the constant, and this is the coefficient of the late value of the differenced open series. This is the R squared value, which is 0.01, and the Durbin-Watson value is 2.013. So after this, I would like to check the ARCH effect. So I will click on view, and after this I will go to diagnostic tests, and under diagnostic tests I will click on heteroscedasticity test, and here I will click on ARCH and then OK. So this is the ARCH test, And the null hypothesis is that this series doesn't have arch effects up to Q, but the p-value of the observed R squared based on chi-square probability is less than 0.05. So we reject the null hypothesis, and we conclude that there are arch effects in this model. So arch effects are present in this model. So after this, I will estimate arch model. So again, I will click on quick and then go to estimate, and here I will write d open -1, and after that constant, and then d, and open -1, and this I should remove this. Here on the method, I will click on arch, and since I am not estimating GARCH, so I will write 0 here, and then I will click the OK, and this is my arch model. So this is the estimation of the arch model. So this is the mean equation. The constant is -0.136, and this value is significant, statistically significant at 5% level. And this is the coefficient for the lag value of the open series in first difference, and this is also significant, highly significant. And this is the variance equation. Its constant is significant, as well as the residual, the value of the lagged residual square is also significant. This is the R square value, and this is the Durbin-Watson, which is 2.54. So after this, I'll check the conditional variance graph. So I will go to view, and here in GARCH model, in GARCH graph, I will go to conditional variance, and this is the conditional variance of the GARCH graph. Now after this, I'll estimate GARCH model, and again D open C D, I will change this to arch, and after arch, I will leave this here, arch 1 and GARCH 1, and let me click OK. So here is my estimated GARCH model. This time I have the mean equation, and this is the variance equation. Now this is the GARCH, the lag value of the GARCH, and that is significant, and this is the residual square in its lag value, that is also significant, and the C value is also significant. R squared value is in minus, and the Durbin-Watson test value is 2.406. After this, I'll estimate TARCH. So again, I will write this model OPEN C D OPEN minus, let me change to arch, and this time here I will do this to EGARCH. Let me copy this, because I will be using this again, time and again. So this is copied, and I'm estimating EGARCH. So this is my EGARCH model, that is exponential general autoregressive conditional heteroscedasticity model. Now I have these coefficients, and all these coefficients in various equations are significant, and this is the mean equation. Both the constant and The late value of the open in its first difference is also significant, and the Darboux-Watson value is 2.334. And after this, I'll estimate some other model if I have it here. So I copied this, and this is my GARCH, and this time I will estimate PARCH, that is power autoregressive conditional heteroscedasticity, and this is my PARCH model. Again, these are the various coefficients of the variance equation, and these are the coefficients of the mean equation. And again, the Darboux-Watson value is 2.40. And after this, let me estimate some other models of this family. This is sorry. Let me do it again. Change it, and this is ARCH. And this time, I'm using FIGARCH model. This is FIGARCH. And if I click OK, this is the estimation of my FIGARCH model. Now I have different types of coefficients. There is D, and this is GARCH in its late. This is the residual square in its late value, and the R square value is now positive, that is 0.014, and Darboux-Watson is 2.013. And after this, I'll estimate one more model, and I will change this into ARCH, and here I will change it into FIEGARCH 11. Now, after a few moments, this model will be estimated, and here is the estimation of the FIGARCH model. These are the coefficients of the mean equation, and these are the coefficients of the variance equation. R square value is again minus 0.0141, and the Darboux-Watson value is 2.31. And after this, I'll use some diagnostic tests. So I click on view, and then I'll go to residual diagnostics, and first of all I will check the normality, and this graph shows that this model doesn't follow normality because the Jarka-Barrett test is significant. So we reject the null hypothesis of normality. After this, I'll check the serial correlation. So serial correlation is correlogram and Q statistics. So I can check these here. These are the various autocorrelation and partial autocorrelation coefficients, and there is no problem with the correlation. And let me also check the ARCH-LM test, and this is the ARCH-LM test, and now this data shows that there are no ARCH effects in this model. So ladies and gentlemen, this is very interesting how to estimate the various models in the ARCH family, and I showed you how to do that in EViews, and I discussed that, and I interpreted these results. I hope this was quite informative and useful for you. Thank you for watching this video, and